So thank you everyone and welcome to this ENG webinar. In this webinar, we are going to give an overview of the second version of the ENG catalog. And to do that, we have Josh, who supervised the project along with several of Jinjin students, Tony, Raja, Harichanna, uh, like and Vishnu. So we are going to invite them to do that. With that much introduction, over to you, Josh. So you can give an overview of the activity.
Thanks, Dinesh. So when we started the SD catalog project, we had a plan for how to come up with this catalog that could be plugged into a lot of the different activities that the Enterprise Neurosystem Group has been working on, and to fill a hole that we saw in different machine learning and AI projects. And we came up with an idea and worked, had a development cycle where we came up with some proof of concept that had some capabilities. And then we were kind of at a standstill as to how we move forward with that. And that was around the time that we found out about this group of people who were going to be focused on helping us move us to the next stage in as part of their classwork. And it was perfect timing for us. And over the course of this last year, the last half of this last year, we've worked very closely every week, meeting up, sometimes multiple times per week. And the process kind of went where we provided feedback on the different iterations that we got an update on every week. It was a very good engagement. We were able to give feedback and then respond to that feedback very well in terms of being able to take it into account and move it to an actual implementation that worked very well. So I'm really happy with the outcome of this last year and looking forward to the presentation and also potentially continuing to work with everyone in the future. So with that, we can pass it on to the group to do the presentation.
Sure, Josh. Thanks for the introduction. So I'm going to start off with giving a high-level overview of what the tool does. So we built a command line tool. So what the tool does and what problems it tries to solve and how it actually works. And then we'll go on to give a small demo and then end the presentation with the future scope and what can be done in the future. So let me quickly share my screen. Let me share the whole window, I think. Are you guys able to see the PPT?
Yes.
Sure. So to give a high-level overview, the idea is any organization, be it a university or a software company, will have a lot of digital assets. So a digital asset in this case can be any software piece, any piece of code like an ML model or a data set or any text document, anything as such. So when there are a lot of digital assets, like tons of digital assets, it's a very hard task to manage them. So the problem this tool tries to solve is managing those digital assets. And then the important thing it does is it makes collaboration easier. So let's say I am working in a software company and I'm working on a problem, and then that problem is pretty new to me and I want to find out people who are working on a similar problem, who have worked before, or people who are interested to work on it. So a tool like this would be an easy way to find collaborators to work on a solution like that. And then it also makes tracking changes easy. So let's say someone built an ML model and I would like to use it. I download it and then I use it, but then in the future the actual owner did some changes. I would like to know what the changes are and try to implement them on my own. So this tool can be used to track those changes too. And these are few problems this tool tries to solve. So coming to the actual tool itself, it's a command line tool. So this command line tool can be used to perform various operations, like we can create the digital assets, like read and download them, update them, and delete, search different assets right from the command line itself. So We'll go on to see how it works. So if we start off from the right of this picture, so the idea is to make the digital asset self-describing by attaching a metadata file to it. So this metadata file will be a single source of truth of the digital asset. It describes what the asset is, what it does, and all those things. So that's the first idea, to associate every digital asset with a metadata file. And then the basic idea of storage is GitHub. So we build the whole solution around thinking that all the digital assets will be stored on GitHub. So this tool is an extension on top of the GitHub CLI. So the Git actually offers a CLI tool in order to perform simple operations like creating repos and managing the repos. So this is an extension on top of the Git CLI, which can be able to perform the customized operations like you can see here. We can search for different digital assets. We can create and update them, download, delete, and we can also subscribe to an asset in order to track the changes. So underneath, the tool uses the APIs from GitHub in order to access the GitHub repos. So when we say creating a digital asset, it's nothing but creating a repo, but then it comes with some extra constraints, like a digital asset must be attached with the metadata. So the tool takes care of checking the constraints and stuff. So talking about the metadata itself, we can see a sample of how it looks like. So it mainly has 4 tags. So the asset name, description, and the topics and associations. These 4 are main. A user can come up with different other tags too, but we primarily check that these tags should be present. So asset name is self-explanatory, and description is, it describes what the asset is, and topics are mainly used for search. So let's say, as I told a scenario before, I want to search of people who are working on the same topic or something. So I can use this. I can use the tool, go to the tool, and then search for a topic, and then see how many people are working or how many assets are already there in the organization. So associations, we made it open-ended. User can give whatever associations they think are associated with a digital asset, but then this can be changed in the future. So this is a sample outline of how the metadata looks like. So coming to the actual demo itself, uh, the first thing we would like to show is how to download this tool. So it's on GitHub. So it's open source, so anybody can go and search for the extension, download it, and test for themselves. So I'm just gonna show how to search for the extension. So you can simply go to Google and then search for GitHub CLI extensions, and then you get a GH extension topic from GitHub. Going there, you can see different extensions that are there. So this is written in Python. So if you go to the language Python, there are only 10 extensions that are there, and you can find the digital assets extension. So you can simply go to this repo, which is already open. This is the repo. It has all the information of the tool, so you can read through and understand what the tool does, its capabilities, and how to use it. So this is a single document which provides everything about the tool. So right from installation to how to use. So in order to install it, you can simply run this command. So even before running this, you should have the GitHub CLI installed. So the GitHub CLI must be installed. You can install from this link. And once the GitHub CLI is installed, you can simply run this command to install the extension. So the extension is already installed on my local. So if you just say gh extension, it shows what commands can be run from this extension to offer. So we can browse different extensions, we can create an extension, install them. So that's what we're using here to install it. So I'll just say gh extension list in order to show what extensions are already installed. So we can see that digital assets is already installed from this. So I've already run this command to install, so anyone can run the command to install it. So in order to know what it does, what the tool does, we can simply run a help command to see the different commands. So I can say gh digital assets and help. So these are different commands that are supported by the tool. So we can create a digital asset, we can update the digital asset, and then we can subscribe to the digital assets, and we can download individual files, we can download the repo, and there's also a search capability in this tool. So I'm going to start off with create, the basic command. this create is used to like create a digital asset on the repo. So even this, in order to know what create does, we can simply run help. So I can say gh digital assets create repo and then say help. So this will show all the commands that should be given in the create command. So the mandatory command is repo name. If see whatever is in the bracket is not mandatory, you can give or not give it. But repo name is mandatory. This will actually be the digital asset name. And then we can give a path from where the files can be uploaded, as we discussed the digital asset itself and the metadata file. Or if we just give the repo name, it will take from the current folder. So I will go ahead and demonstrate one create. So the intelligent part of this tool is, as we told, every digital asset must be associated with the metadata. So let's say a user doesn't know this, he did not read the documentation properly, and then there's no metadata associated. He directly wants to upload the digital asset directly. So this tool takes care of that. We can directly create a metadata file from the tool itself. So we're not constraining the user saying you have to come up with a metadata file. So we can create it on the fly too. I'll just show that part. So the digital asset is already there. I'm just deleting the metadata file. And then let's try to create a digital asset. So I'll say gh assets and give the repo name. Okay. This is spelling mistake. Let's see. So it says that files must be uploaded when creating an non-empty repo, and then it shows what are the current files. So you can either say yes, go ahead and upload it, or then say no, change directory, or give a path as it suggests. So I'm just gonna say yes because these are the files I want to upload it. And then it comes up with a prompt saying the metadata file is not found, but it is a mandatory thing to have for a digital asset. So it gives us an option to create it interactively, or we can go ahead and create it manually too. So in this case, I'll say why and create it interactively. So it asks for the asset name. So I can say, I can give them the asset name, and then it asks for a description. So this sample description. And then we have topics. So if you see the sample metadata file, topics are the important aspect of the metadata. It is actually used for searching. So for example, I'm creating an ML model. I will associate it with a topic called machine learning. And then if I want to see what machine learning assets are already there, I can simply search for this topic. So topics are mainly used for search. Let's say there's no topic which you want. So you can go with others and then add your custom topic too. For now, I'm gonna select machine learning, and then even after selecting a tag which is a predefined tag, you can also give custom topics. So you can say why, and then using comma separation, I can give new tags for this. Say test. And then it asks for association URLs. So I can give let's give a sample URL. This will go ahead and create the digital asset in our GitHub. So I'll show the digital asset. So this is the asset which we created. So it will go ahead and upload all the files. So this metadata.json was not there. Our tool created it based on whatever we gave in the command line. So it creates a metadata file, it uploads all the files, and then we have the description and tags updated. So we have a mandatory tag called ens-asset. This is used to classify everything as a digital asset. So if you want to know what all digital assets are there irrespective of the tags, so you can just search for this tag, so it lists all the digital assets. So this is create. The same way we can also update files. So let's say I want to update a data file, so I can use the update file command. So see, assets. If I'll just say help in order to know. what commands it takes. So it asks for the update type. You can either update data or metadata. So data will be all the data files here, and then the metadata is just the metadata or JSON. So, and then we can give a file path, or if we don't give a file path, it will directly take from the current directory as before. So I'll just demonstrate a way where, let's say, user wants to update the metadata, but he's missing an important tag. So description is a mandatory tag to be present, but let's say he deleted it or something happened and then he wants to update it. So the tool takes care of this, and then it will prompt the user to add the tag. So I'll just show that part. Say update file, then go with update type, say metadata. Then the path is already, I'm already in the path, so I'll just say into. We'll have to give a repo name. So it will go ahead and read the metadata or JSON from the local and then say that a description is not present. It is a mandatory tag to present. So it will ask us either we can add interactively or we can go ahead and updates file. I will do it interactively and then I can give a description. So this will go ahead and update the metadata file for us. So this description. So this is update. In the same way, we can read files, we can download the repo itself, and we can also download an individual file from the repo. So another important capability of this tool is search. So as I've demonstrated in the first part of the presentation, I want to search on a topic where I want to find collaborators. So search the search command. Say help to see what commands it takes. So we can either search by name, we can either search by topic or keywords. So name directly searches for the repo name here, and then the topics is topics we give for the repo. It will go into the topics. Let's say I want to search for machine learning topic. It lists all the repos with that topic. So I'll go with name and then say I want to search with name. So let's say search and give the name test. So there are like 30 digital assets that we created with name test. So it's a fuzzy search. So whatever repo has the name search, I mean test, directly gives it. So it'll show the author and then the link to the repo. So I can go ahead and go to the link, see what the work they have done and all that stuff. So we can also search by topic. This is just the name. We can also do the same thing with topic and keyword search. So what the keyword search does is it goes into the metadata files and then it searches for key whatever key we give in the metadata file. So that's there for search. And another capability this has is subscribe. As I told, I downloaded a digital asset and then the author did some changes. So I would like to know what changes have been done. So I can simply subscribe to the repo once I download it. Assets minus subscribe and see what commands it takes. Assets. So subscribe repo just takes the repo name, so I can say the repo name and skip the asset which I created just now. So this will go ahead and subscribe. So I can also list the repos which I already subscribed to. So there's a command called list subscribed get subscribed repos. So that's I can say get So I subscribe to 3 repos, so I can track changes that have been done to these repos. So we can also do it this way, where whenever there's a change, we can get a mail saying this change has been done. But now we have to search for the command line and then see if there are any changes. So I can just say get status in order to know the changes, but it can also be automated so that we can get a mail. So I'll just show the get status command, how it works. Status and then give the repo name. So we just created the repo, there are no changes. So now we can do a small change and then um, test for that. So I just change the description in this case, but we can also change the data file and any changes. So I'll just use the update file in order to update this. Data and I'll update. So we updated the description. Now we can run the get status and to see changes. So this will show that there is some change happened, and we can go to this blob URL to know what changes have been done, and then we can download the repo again. So these are a few capabilities that this tool provides. So from a digital asset perspective, we can manage each and every aspect of the digital assets right from the command line. So even though it's on GitHub, we don't need to know GitHub functionalities like commits and all that stuff, because in the future, if we move it to a different platform, we don't want to be constrained by the things of GitHub. So yeah, this is it. Let's go to the next part of the presentation. Um, and then we like to end this presentation by discussing the limitations and the future scope of this project. Chen-
So yeah, I'll carry out. I'll be taking you through this slide. So the limitations and future scope of this project. So the first limitation is that through the command line, we have ensured that every digital asset must contain a metadata file, but the user can bypass this constraint. Like if they create a digital asset directly from GitHub, there is no restriction to have a metadata.json file. So that constraint can be bypassed by directly creating from GitHub. And the second constraint is that we cannot store large ML models in the public GitHub repos. So right now our command line only is based on GitHub. So we might face issues for large ML models. So in that case, you might have to use Git large file storage or some platform like Hugging Face for sharing and storing ML models. So the future scope for this project is it can be extended to other platforms like AWS. Right now, it only supports Git, so we can only store our assets in GitHub. So it can be extended for other platforms like AWS or MongoDB or anything as such. So these are the limitations and the further scope for this project.
Yeah, so this is the end of the presentation. So